So I'm going to go over these couple of slides together. And my intention is not to go and teach you all of the material, but simply to give you some test taking strategies to just help you improve the things that you already know. So let's start with the first one. And, a lot of the SAT is about reading and being able to pull important information out of here. So it gives us a formula and says the equations, I'm reading here, the equations above show the total cost T, so T is total, for shipping C units closer to the location and F units farther. They try and use letters that make sense. They can't always do that, because sometimes they mean different things, but they do try and do that. And so that's helpful. So it says that the total cost was 47,000. That's going to be our T. So 47,000 is equal to 300 units were shipped to the farther location. So that's F. So, and then it says how many were shipped to the closer location. That's C. So we're trying to solve for C. So I'm going to write 5C plus 12 times 3,000 were shipped to the farther location. So 12 times 3,000. So this, once we get to here, this is a pretty manageable algebra question, but just making sure we plug things into the right spot. All right, so I do believe this is part of the non-calculator part. I did write that up there. So let's see, this is going to be 3,000 times 12. Well, I know 3 times 12 is 36, and add the zeros. So that's 36,000. And then I'm going to subtract that to the other side. So 47,000 minus 36,000 would be 11,000 is equal to 5C. And then we're going to divide both sides by 5. And so I saw a lot of you guys do this, which is great. Just the old school division, 11,000 divided by 5. So 11 goes in, 5 goes into 11 twice. 2 times 5 is 10. We subtract and bring down the next number. 5 goes into 10 twice. Okay, we subtract and bring down the next 0, and those are going to be zeros. And know that the answers are always at the bottom right of the slides, but our answer is 2,200. So when you fill them in and the grid in, we're going to write 2,200 up here, but don't forget that we have to bubble that in because the bubbles are what is going to be graded. So make sure that you do those nicely for each of these grid in questions. All right, next, and I'm just going to roll through. If you guys have questions, just stop me, okay? So we have the absolute value. Well, remember, absolute value means distance. So the stuff that's inside here, the stuff that I have highlighted, could either equal -5 or +5, and that would be a true statement. So those are going to be the two equations we're going to write. 2x plus 1 is equal to -5, or 2x plus 1 is equal to +5. So we're going to write that as two equations. And then we're going to solve both of them, and those are going to be my A and B solutions. So I have 2x is equal to -6, and x comes out to be -3. Or 2x is equal to 4, and x is equal to 2. So now those are my A and B. So I'm going to plug those into here. I'll plug in that for A and that for B. So I have the absolute value of -3 minus 2, which is the absolute value of -5, which is +5. When you bubble that in, you can put it all the way to the left like this, or you can put it all the way to the right like this, but you cannot put it in between. If you do, it will be marked wrong. So you just put it all the way to the left or all the way to the right. Don't fill in the other thing with zeros. Don't fill in any other bubbles. Just put your answer left justified or right justified. Okay, now, and that's kind of important. Wouldn't it be a shame to know the correct answer and get it wrong because you bubbled it in incorrectly? All right, for the next one, Juan purchased an antique that had a value of $200 at the time of purchase. Each year, the value of the antique increased 10% over its value from the previous year. I thought this was one of the harder ones. We haven't talked much about this. We will later on in class, not today's class, but I mean further down the school year. But there is a formula that we're going to use here, and that is that the final amount typically equals the initial amount, and this is for simple interest. So 1 plus our rate for a certain amount of time. Okay, it says, and we don't need that whole equation for this problem. Let's see, it says $200 at the time of purchase. Well, that's the initial amount. Okay, $200 is the initial amount, and that almost always goes right there in front. And it increased 10%. So as a decimal, that's 0.1. So it's going to be 1 plus 0.1 or 1.1. And t is time, it says 2 years. So if you got this far, you're in good shape. Okay. Now, the answer is worded in kind of an odd way. So it says if the answer is 200A, where A is a constant, what's the value of A? What that means is we're trying to find this. That's like our A. So we want to find 1.1 to the second power. And so that would be 1.1 times 1.1. And we just do this old school multiplication. 1 times 1 is 1. That's 1. That's 1. That's 1. Add down. I move over 2 decimal spots. And so the answer is 1.21. So again, either left justified or right justified. I guess in this case we have 1.21, so it doesn't matter. But make sure you bubble in 1.21. All right, any questions on the first slide? Okay, I'm going to keep rolling here. And for the next one, as I watched you guys work, I saw a lot of people trying to solve this system. You'll get the right answer that way, but always be careful that they're very tricky about how they word things. Given this system, they want to know what is 5x plus 5y. Well, just looking at this, I can see if I add them down, I get 5x, okay, 3x plus 2x, and 3y plus 2y would be 5y. So 5x plus 5y equals 2,500. That's my answer. 2,500 is my answer. I forgot my little grid over here, but we would want to grid that in. Next problem, number 20. When you see this here, everybody, that screams factoring, okay? If you see a difference of squares, it screams factoring. It's probably going to be a factoring problem, and in fact, this one is, because that right side factors into u minus t times u plus t. And then we have, of course, that u minus t out in front. So if we factor that, now it says u plus t is equal to 5. That's going to go in there. U minus t is equal to 2. That's going to go there and there. And so the answer is 2 times 2 times 5. So 4 times 5 is 20. So, all right, notice what I did here in how elementary the math is. What did I really do? I added 3 plus 2. I added 1,200 plus 1,300. Okay, but you have to know what's being asked. In this one, we factored a difference of squares. You guys have been doing that forever. Okay, but you have to be able to realize some of those cues. And so I'm just trying to give you some of those cues as we move along on this test. The next question that starts the calculator section And I think you'll find that you typically don't need a calculator to do the questions in the calculator section. They just allow you to use it. Like in this one, there's no reason to use one. So a helicopter is hovering at 40 feet above the ground. It gains an altitude at a rate of 21 feet per second. Well, when I see 21 per something, that screams slope. That screams changing. So it should be connected to a variable. Just by knowing that, I have a 50-50 chance of getting this problem correct. Okay, just by knowing something that changes per something is going to be a slope. Oftentimes, if it's a linear relation. And so if it's hovering at 40 feet above ground, that means it started at plus 40 feet and then went up at 21 feet per second. So the answer is B. Okay, this is part of the calculator part. Obviously, I'm not using a calculator. Okay, next one. Flat fee of $5. That screams y-intercept. Okay, and let's see. Flat fee of $5 per month for up to 100 text messages plus 0.25 for each additional message. So that means that it's going up at 0.25. So this is a positive y-intercept, and then it's going up. And so this is going to be our answer, because we're starting at 5 and then it's increasing, as opposed to starting at 5 and then decreasing like that one. You know, it doesn't increase right away because it says we get 100 messages for the first $5. Okay, and it certainly doesn't decrease right away. All right, problem number 3. Let's see. Jake is eating popcorn. He eats half of the popcorn during the first 15 minutes. Then he stops for the next 30 minutes. So the amount of popcorn he's eating is going down. Then he stops, so it stays the same amount. Then he gradually eats the popcorn, so it's still going down. And then he spills it, so it's all gone. Okay, it like instantly drops off. And so our graph is going to be something like this. Okay, so just being able to interpret what's happening in that graph. Next, this is a very easy algebra question. The only trick to this is they don't want to know what x is, they want to know what 3x is. Don't fall for their trap. So if you solve this for x, which all of you guys can do, you know, I could do it a number of ways. Move the 20 over, I get negative x equals negative 5. And so x comes out to be 5, but that is not the answer. I want 3 times 5, which is 15. So just be careful, because that will come up again on the test. You know, again, it would be a shame to know the answer and then just rush through it and not get it correct. Problem number 5 is all about notation. If you know what the notation means, if you know what this means, it is an easy question. If you don't know what this means, you're guessing. What it means is -1 is our input. Plug that in for x. So -1 plus 3 is 2 over 2, and the answer is 1. That's it. So what did I do? And I added, I divided, right? But I have to know what that notation means. And so that f of -1 means an input of -1 in for x. All right, last slide. Which of the following is equivalent? I would say no real shortcuts here, but this is, you know, we're just distributing. That's going to be 2x to the third. Remember, we add the exponents, minus 6x squared. For the next problem, problem number 7, retail company has 50 large stores located in different areas. And this is a great question. We don't do much of this stuff. And so for you guys to be able to see some of these before you were to take the actual test. It says a researcher for the company believes that an employee job satisfaction varies greatly from store to store. So some stores are very happy, some are not. There's everything in between. And they want to sample. They want to know what sampling method is most appropriate to estimate the proportion of all employees in the company who are satisfied. So selecting one of the 50 stores at random and then surveying, that's not a good idea. You're only going to find out what happens at that one store. We want an idea of what's happening with all of the employees. Selecting 10 employees from each store at random and then surveying each employee, that sounds like a pretty good idea because we're representing all stores and it is random at each store. Surveying the 25 highest paid employees and the 25 lowest paid employees, probably not the best because you might kind of assume the highest paid people will be happier and the lowest paid people are going to be not as happy. And so you're kind of skewing your data in that case. Creating a website on which employees can express their opinions, probably not the best method due to availability, people who will take the time to go on and do that, things of that nature. Some people obviously don't have the means to get on a website at home and might not do that if you're doing it outside of the workplace. So the answer is B. All right, last one. Nope, second to last one. So we have two girls. The two graphs above show the total amounts of money that Ian and Jeremy have deposited into their savings account for the first 7 weeks. How much more? So be careful. How much more did Ian deposit each week than Jeremy? So, well, we can say that Ian deposited more each week because actually Ian started with less than Jeremy, but he grew at a greater rate, as a greater slope. So this is a slope question. So notice that Ian is putting in $100 each week. I mean, every week it goes up 100, then it goes up 100, then it goes up 100, then it goes up 100. So he's adding $100 each week. Jeremy is putting in $50 each week. He starts at 300, goes up 50, up 50, up 50, and so on. So how much more did Ian put in each week than Jeremy? $50 more a week. All right, so again, I want to reiterate, the math is more about, can you interpret the information? Can you read clearly and pull the information out? Can you interpret the graph and get the data, the information from the graph? There is some of this stuff too. This is a notation question that if you know what this notation means, it's very easy to do or manageable. And if you don't, then it's a total guess. So now you've seen it. H of 5 means an input of 5. So we do 2 to the 5th. 2 to the 5th is 32, just like the Kahoot from the beginning of class. H of 3 means an input of 3. 2 to the 3rd is 8. Okay, 32 minus 8 is 24. So just taking 2 to a power and subtracting, not bad if you know what the notation means. Any questions on any of those that you would like me to go over again?